A solution which obeys Raoult's law, not at particular concentration and temperature, at all concentration range and temperature, is called as ideal solution. The intermolecular force of attraction between solvent solute is equal to solute solute as well as what? Solvent solvent. Solution which does not obey Raoult's law at all concentration and temperature is called non-ideal solution. Hello, my dear students. I am Renuka Ashok, Department of Chemistry, Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. My dear student, today I am going to discuss about the 5th session of chapter Solutions. 5th session of chapter Solution. Okay. In the previous session, I discussed about, that is in the 4th session, I discussed about vapor pressure of liquid solution, as well as I discussed about Raoult's law, and I compared Raoult's law as well as what? Henry's law. Today in this session, I am going to explain about two types of solution. One is ideal solution and second one is non-ideal solution. Already in first PUC heard about two types of gases, ideal gas as well as what? Real gas. In solution also there are two types of solution, ideal solutions as well as what? Non-ideal solution. So ideal solution and non-ideal solution and its properties, the difference between ideal solution and non-ideal solution. And in non-ideal solution we have two types, non-ideal solution having positive and negative deviation. Last I am going to discuss about azeotropic mixture. Azeotropic mixture. Therefore, my dear student, today's session is completely about the type of solutions. Like there are how many types of solutions? Two types of solutions, ideal solutions as well as non-ideal solutions. In non-ideal solution, once again we have two types of solution, non-ideal solutions having positive deviation as well as non-ideal solutions having negative deviation, as well as last topic, azeotropic mixtures. Let us consider binary solution. Already in the first session of solution, I discussed about binary solution. My dear student, what are binary solutions? Solutions which having two components. In that one component is solute, another component is solvent. Solvent is the part which is constitute of major portion of the solution. A minor portion of the solution is called as what? Solute. These binary solutions are classified into two types. One is ideal solution, one more is non-ideal solution. What are the two types of ideal solution? What are the two types of solution? The two types of solutions are, first one ideal solution, second one non-ideal solution. Now, when you consider component A and B or component 1 and 2, either you take component as A and B or you take component as 1 and 2. According to Raoult's law, P is directly proportional to X. The partial pressure of the component is directly proportional to the mole fraction of that component. If I consider A as component, PA is directly proportional to XA, PB is directly proportional to XB. If I remove the proportionality sign, PA is equal to PA naught XA. PB is equal to PB naught XB. PA and PB are partial pressures of component A and B. XA and XB are the mole fractions of component A and B in its liquid phase, as well as PA naught and PB naught are the vapor pressure of pure components. Vapor pressure of what? Pure components. So, when you want P total, so is equal to PA plus what? PB, PA plus PB. So, PA is PA naught XA, PB is PB naught XB, that is P total. P total is equal to PA naught XA plus PB naught XB. So, these are the mathematical form of Raoult's law. What are the mathematical forms of Raoult's law? The mathematical form of, you know about what? Raoult's law of binary solution. What are the mathematical form? PA is equal to PA naught XA, PB is equal to PB naught XB, PB naught XB. These are the two mathematical forms of what? Raoult's law. Why I am explaining this? Before starting ideal solution as well as non-ideal solution, my dear student, some of the binary solution which obeys Raoult's law, some of the binary solution that does not obeys Raoult's law. Those obeys Raoult's law at all concentration, range and temperature. A solution which obeys Raoult's law not at particular concentration and temperature, at all concentration, range and temperature is called as ideal solution. What are ideal solution, my dear student? A solution which obeys Raoult's law. A solution which obeys Raoult's law at all concentration range and temperature is called as ideal solution. Very beautiful example for ideal solution is benzene and toluene. Don't put comma. Benzene, don't write example as benzene, comma, toluene. Benzene, comma, toluene. Don't write like this. You write benzene and toluene or benzene plus toluene. Benzene plus toluene. N-hexane and N-heptane. Chlorobenzene and bromobenzene, carbon tetrachloride and silicon tetrachloride. Carbon tetrachloride and silicon tetrachloride. What are the beautiful example for ideal solution? Benzene and toluene. Benzene and toluene. N-hexane and N-heptane. N-hexane and N-heptane. Chlorobenzene and bromobenzene. Chlorobenzene and bromobenzene. Carbon tetrachloride and silicon tetrachloride. These are the example for ideal solution. Once again, I'll repeat, my dear students. What are ideal solution? Solution which obeys Raoult's law at all concentration, range and temperature is called as what? Ideal solution. For example, in case of ideal solution, when I consider this as a solvent is made up of molecules AA as well as this is solute B dot dot B. When both are mixing solvent and solute, it will become what? Solution. The molecules are AB. Molecules are AB. Solvent is A dot dot A. Solute is B dot 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 B. When they mix together, it will give A dot dot B. It is solution. It is solution and it is solvent and it is solvent and it is solute and it is solute. When you mix solvent and solute, it gives rise to solution. In case of ideal solution, the intermolecular force of attraction in solute-solvent mixture is equal to intermolecular force of attraction in solvent and solute. Solvent and solute. The force of interaction between solvent and solute and the mixture is this intermolecular force of attraction is same for which type of solution? Ideal solution. For ideal solution, intermolecular force of attraction for solution is equal to intermolecular force of attraction between solute and solvent molecule. So, because of that, in ideal solution, solvent-solution interactions are equal to solute and solvent respectively. Because of that, volume after mixing is equal to 0, enthalpy after mixing is equal to 0. That is, there is no change in volume and there is no change in enthalpy after mixing. Why there is no change in volume and there is no change in enthalpy after mixing? Because the intermolecular force of attraction present in solution is equal to solute and solvent. That's why for ideal solution, volume after mixing also 0, enthalpy after mixing also 0, as well as they should obey Raoult's law. Again, what are the characters of ideal solution? The characters of ideal solution, they should obey Raoult's law. Volume after mixing is equal to 0, enthalpy after mixing is equal to 0, and in ideal solution, solvent-solute interactions are equal to solute and solvent interaction. Solute and solvent interaction. Therefore, the very important question, what are the values of volume and enthalpy after mixing for ideal solution? For ideal solution, the value of volume mixing as well as enthalpy change is always equal to 0, and these solutions obeys Raoult's law, and intermolecular force of attraction between solvent solute is equal to solute as well as what? Solvent. Okay. Next, consider non-ideal solution. If you know about ideal solution, it is very easy to give definition for non-ideal solution. What are non-ideal solution? Solution which does not obey Raoult's law at all concentration and temperature is called non-ideal solution. A solution which does not obey Raoult's law. A solution which does not obey Raoult's law at all concentration range and temperature is called non-ideal solution. Is called non-ideal solution. Their character, they should not obey Raoult's law, and volume after mixing is not equal to 0. Enthalpy after mixing is not equal to 0, as well as the force of attraction between A and B is greater than or less than that of A and BB. For a case of ideal solution, the force of attraction present between A dot dot B, that is solute solvent mixture, is equal to the force of attraction present in solvent, that is A dot dot A and solute B dot dot B. But in case of non-ideal solution, the force of attraction between A dot dot B not equal to the solvent and solute. Solvent and what? Solute. Either it is greater than or it is what? Less than. Based on that, non-ideal solution and further they are classified into two types. First, I will explain what are the differences between ideal solution and non-ideal solution. The very important question for your board, write any two differences between ideal solution and non-ideal solution. Ideal solution, first one, they should obey Raoult's law. Here they do not obey Raoult's law. Volume after mixing 0, here volume after mixing not equal to 0, H after mixing 0, H after mixing not equal to 0. The intermolecular attractive force between A dot dot A and BB and AB are what? Same. Here the intermolecular attractive force between AA and BB and AB are not same. These are the four important differences between ideal solution and what? Non-ideal solution. For your board exam, they'll ask 2 mark very important question, but I mentioned 2 points. What are the differences between what? Ideal solution and what? Non-ideal solution. Next, I'll consider the classification of non-ideal solution. Non-ideal solutions are further classified into two types. Non-ideal solution with positive deviation, non-ideal solution with negative deviation. Non-ideal solution with positive deviation, non-ideal solution with negative deviation. What are the two types of non-ideal solutions? The two types of non-ideal solutions are non-ideal solution with positive deviation, non-ideal solution with what? Negative deviation. Today, in this session, I am going to explain both type of non-ideal solution. First type is non-ideal solution with positive deviation. Positive deviation. What is non-ideal solution with positive deviation? Here, solution in which its total vapor pressure is higher than that of ideal solution of same composition and temperature. Total vapor pressure of solution is higher than that of ideal solution of same composition and temperature are called as solution with positive deviation. Solution with what? Positive deviation. Solution with positive deviation, they deviate from Raoult's law. Partial pressure of each component, that is P and PB, are greater than what we calculated from Raoult's law. Okay, so the partial pressure or vapor pressure of each component is higher than that of what exactly it is calculated from Raoult's law. That is, it is greater than PA naught XA and it is greater than PB naught XA. Why the pressure is greater means, in this solution, the intermolecular attractive forces between the solute-solvent molecules are weaker than those of between solute-solute as well as solvent-solvent interaction. The intermolecular force of attraction of solute-solvent mixture is weaker than solvent and solute. Solvent and solute. The mixture, solute and solvent, after mixing, the intermolecular force of attraction of that mixture is always weaker or lesser than that of two components, solute and what? Solvent. Because of this weak intermolecular force of attraction between A and B, so when the force of attraction between very less in between two molecules, what the molecules has a tendency? It has a tendency to escape from the system. Therefore, the solute and solvent mixture, it is not possible to present in the beaker. They want to escape from the system. When it escape from the system, pressure increases, and they results in what? Positive deviation. This means that in such solution, molecules of A or B will find it easier to escape than in pure state. This will increase the vapor pressure and result in positive deviation. Due to decrease in magnitude of intermolecular attractive forces, the molecules are loosely held and thus increasing intermolecular distance. Therefore, formation of non-ideal solution is always associated with increase in volume as well as absorption of energy. Non-ideal solutions, because of weak intermolecular force of attraction, between A and B, it has a tendency to escape from the system. Therefore, its pressure increases. And because of weak intermolecular force of attraction present between A and B, the molecules of A and B, they does not come closer. Because of weak intermolecular attraction, they are trying to go away from each other. Therefore, volume increases as well as absorption of energy takes place. Therefore, observe the graph of non-ideal solution having positive deviation. Already I explained that according to y-axis you take vapor pressure, according to x-axis, along x-axis take mole fraction, positive deviation. We are getting what? So, curves. Okay, having positive deviation. This shows PA and this is PB and this is PA naught and it is what? PB naught, and it is vapor pressure of, this is represents what? Vapor pressure of solution. Therefore, for non-ideal solution having positive solution, so partial or vapor pressure of component is greater than what we expect from Raoult's law. That's why PA is greater than XA PA naught, PB is greater than XP PB naught. Mixing, delta H mixing as well as delta V mixing, both are positive. For example, for acetone ethanol, acetone CS2, water methanol, water ethanol, carbon tetrachloride and toluene. The example for non-ideal solution having positive deviation, water methanol, water ethanol, acetone CS2, acetone ethanol. Now, you take non-ideal solution having which deviations? Negative deviation. What I explained for positive deviation, that is you explain it exactly opposite for negative deviation. What I explained? There the total vapor pressure is greater than that of what is ideal solution having same copper. Here the vapor pressure is what? Lower than that of ideal solution of same composition and what? Temperature, are called solution of having what? Negative deviation. For solutions having negative deviation, partial vapor pressure of each component A and B is less than that of what we calculated from Raoult's law. That is PA is less than that of PA naught XA, and PB is less than that of PB naught XB. Therefore, in case of positive deviation, partial vapor pressure of each component is greater than what we expected from Raoult's law. Non-ideal solution having negative deviation, the partial vapor pressure is less than that of what we expected from Raoult's law. Boiling point of such solution is relatively higher than the boiling point of A and B respectively. In this case, the intermolecular attractive force of solute solvent, that is AB, is stronger than here solvent and solute. In such solution, molecule of A and B, because of the intermolecular force of attraction is very strong between A and B, the molecules come closer and the volume decreases with liberation of energy. Because of that reason, so negative deviation, the PA is less than what we expected from Raoult's law, PB is less than what we expected from Raoult's law, delta H and delta V mixing is equal to negative. And what are the examples? Acetone alanine, acetone chloroform, methanol acetic acid, water nitric acid, chloroform diethyl ether, water HCl, acetic acid pyridine, chloroform benzene. Board example, remember water HCl and water HNO3. These are the two easy examples to remember for non-ideal solutions having negative deviation. My dear student, you remember the easy example water HCl as well as water HNO3. Okay. And the graph of non-ideal solution having negative deviation, once again vapor pressure versus what? Mole fraction. We'll get a graph like this. Okay. So this is a graph for non-ideal solution with what? Negative deviation. Okay. The last topic of this session is azeotropes or azeotropic mixture. Azeotropes are azeotrope mixture. Some of the binary liquid mixtures, some of the binary means what? Two component. Some of the binary liquid mixtures have same composition in both liquid phase as well as what? Vapor phase. Liquid phase as well as what? Vapor phase. Some of the binary liquid mixture, they have same composition in their liquid phase as well as what? Was vapor phase, or they boil at constant temperature. They are called as azeotropic mixtures. Azeotropic mixture. What are azeotropic mixture? Binary liquid mixtures having same composition in their liquid phase as well as what? Vapor phase, as well as they boil at constant temperature, are called azeotrope. There are two types of azeotropic mixture: minimum boiling azeotropes and maximum boiling azeotrope. What are the two types of azeotropic mixture? Minimum boiling azeotropes as well as maximum boiling azeotropes. Okay, let us consider minimum boiling azeotropes. Minimum boiling azeotrope. What are minimum boiling azeotropes? The solution which shows large positive deviation. The solution which shows large positive deviation from Raoult's law. Such a solution, such liquids are called as minimum boiling azeotrope. Minimum boiling azeotrope. Very good example for minimum boiling azeotrope: ethanol 95.5% and water 4.5%. Ethanol 95.5% and water 4.5%. Ethanol 6.8% and chloroform 93.2% and chloroform 93.2%. So what are the beautiful example for minimum boiling azeotrope? What are minimum boiling azeotrope? Minimum boiling azeotropes which show large positive deviation from Raoult's law. Example for minimum boiling azeotropes are ethanol 95.5%, water 4.5%, ethanol 6.8%, chloroform 93.2%. Next, maximum boiling azeotrope. Maximum boiling azeotrope. The solutions which shows large negative deviation from Raoult's law. The solution which shows large negative deviation from Raoult's law are called as maximum boiling azeotrope. HNO3 68%, water 32%, H2O 43%, HI 57%. These are very beautiful example for maximum boiling azeotrope. So, maximum boiling azeotrope is nitric acid 68%, water 32%. Nitric acid 68%, water 32%. Next example, water 43%, hydrogen iodide 57%. Therefore, I completed what are azeotropic mixture and what are the types of azeotropic mixture, minimum boiling azeotropes as well as maximum boiling azeotrope. What are azeotrope? The binary liquid mixtures having same composition in its liquid phase as well as what? Vapor phase. They are called as what? Azeotrope. There are how many types of azeotrope? Minimum boiling as well as maximum boiling. Minimum means they shows large positive deviation from Raoult's law. Maximum, they shows large negative deviation from what? Raoult's law. You remember one example, minimum boiling azeotrope, ethanol 95.5%, water 4.5%, maximum boiling azeotrope, nitric acid 68%, water 32%. Okay. Next, what are the difference between non-ideal solution having positive deviation and non-ideal solution having negative deviation? As I discussed earlier, non-ideal solution having positive deviation, so the partial vapor pressure of each component is greater than what we expected from Raoult's law. Non-ideal solution having negative deviation, partial vapor pressure of each component is less than that of what we expected from Raoult's law, and attractive force between AB is weaker than A and BB here. Stronger than AB is stronger than A and BB. Therefore, what are the differences between positive and negative deviation? Positive, delta H after mixing is greater than 0. Here it is less than 0. Volume after mixing it is greater than 0. Here less than 0. Attractive force between AB is weaker than A and BB. Attractive force between AB is stronger than A and BB. They form minimum boiling point azeotropes. They form maximum boiling point azeotrope. These are the differences between non-ideal solution having positive deviation and what? Negative deviation. My dear student, in this session, I discussed about the type of binary solution like ideal solution which obeys Raoult's law, non-ideal solution which does not obey Raoult's law. Under non-ideal solution, there are two types. Non-ideal solution having positive deviation, non-ideal solution having negative deviation. I discussed everything, characters and properties of non-ideal solution and ideal solution. I discussed about what are the differences and I discussed about graph. Finally, I discussed about azeotropic mixture. In azeotropic mixture, there are two types, minimum boiling azeotropes as well as maximum boiling azeotrope. Next session, I'll come up with the important topic and new concept that is called as colligative properties. Which type of properties? Colligative property. Therefore, my dear student, next session, I'll come up with a new concept called colligative properties. Until that, goodbye. Thank you.